So we know what sets are. Sets are basically, in a way, you can say group of elements, and that group of elements can be heterogeneous. We have integers, string, boolean all together in a set. Normally, more often than not, you might find homogeneous kind of sets, but they can be heterogeneous. So you have a set like that, and you can create a set. In set, you don't access things with index. There is no concept of a order. So we cannot say 10 is the first element, life is the second. All we say is 10, life, and true are elements of the set. And there is no option of subscripting. So that's an error. This concept doesn't hold here. It's not a list. It's not a tuple. It is a iterable, by the way, but it's not a list and this. Then one this in fact this in you have seen earlier also, for lists also you can check whether something is in that list or not in the list. Same holds for string, sorry, set also. You can check that in and not in. Often you might find code like this, that you are checking a condition if a specific element is present or not. Accordingly, you do something. So that's fine. You can have a set of things, and of course, you can have a set of anything. You can have a set of tuples, and you can mix things, right? So you can create a set like this. One important thing to note is that uh, the element of the set must be immutable. Okay? So you can have a tuple, no problem. You can have a tuple of tuples, nested kind of tuple, no problem, because tuple is immutable. Strings are also immutable. So all that works. This one works because you have tuple. But if you come to this one, here we have a trouble. And the trouble is that this list is mutable. Okay? It can be modified. It's an object which can be modified. So that's not allowed. And if you do something like this, it gives an error, unhashable list. And uh, let's do something with a dictionary. Let's say we have a dictionary D1 uh, empty, and now you want to add an element. So you will say D1 of maybe Ram is 12. But let's say you don't want a string as the key, you want a tuple as a key. Sorry, you want a tuple as a key, no problem. You can have a tuple. Let's say you want to say D1 of 3, 4 is 12, and then let me print D1. Works fine, no problem. But if you make it a list, if you say D1 of that list, which is a mutable object, is 12, then it will give an error, and the error is very similar, unhashable type. So what we are saying is that whether we are talking of a key in a map or we are talking of the value in the set, they must be totally immutable. Totally immutable in the sense that even deep down, let's say I'm talking of this cell works right now. Even deep down, you should not have a modifiable object. Like if you have a list here, then this tuple is kind of contaminated with mutability. Some part of it can be modified. So again, it will say an error. Okay, so yeah, it gives an error, unhashable type list. So even nested down, there should be no mutable object. It holds for the um, value in set and key in map. Now, why it holds? It has to do with somewhat with the internal implementation. Also, internally, both map and set are implemented as hash tables. Okay. So, what in a map? Let's say, let's understand a map. So you have a hash table, which is basically an array of elements. And if elements collide, then there is a sequence, I mean, concept of bucketing. You can if multiple keys map to the same index, they can be chained together, linear chaining kind of stuff. And how do you get the index in that array where that element is to be stored? So the way is this, that you have the key and you apply the hash function on it. You apply the hash function on it, and that hash function returns the index. And then you go to the index and store it. So so the basic thing is the key must be hashable. The key must be hashable. You must be able to compute the hash index on that key. And if the key is mutable, if the key can modify its value, then it's very troublesome. You hashed, you stored that element at some index, then the key modified, and when you apply the hash function, it is returning a different index in the array. So that doesn't work. So this unhashable type has to do with that I cannot use this non-constant thing as a input to the hash function. It must be a immutable thing. So this is one aspect. Normally, you never store modifiable things in a set. And whether it is map or set, they are very much similar. In the set, basically, you can imagine that we are only having value. So the hashing is happening on value and things are stored. In the map, the key and value are separate. And in set, we only have the value, or you can say it is both the key and the value. But but otherwise, many concepts apply in the background implementation in the same way. So can be heterogeneous, of course. Uh, what can be done on sets? If you do DIR, you can memorize. I mean, remember those school days where you use union, intersection, difference of sets, A minus B, symmetric difference of sets. That means A minus B, union B minus A. Those kind of things. Sets are good in that thing. In a set, a thing cannot repeat. So sometimes when you have a list and you want to get rid of anything which repeats, then you can very easily typecast it to set and again typecast it to list. You get rid of duplicate things. So nothing can repeat there, and they are good in taking union, intersection, difference, taking subset and superset. Okay, those kind of things they are very good in. Taking membership, of course, we have seen that in that's not a big deal. We have seen that taking membership. Iterating on the sets are iterable. You can iterate, you can look at process each element of the set. There is no guarantee on the order. Okay, it could be anything. So like I created a set 10, 20, 30, 40, but when I iterated, I got some different order. Doesn't matter. Naturally, they cannot duplicate things. If you specify an element multiple number of times, it will be only once. And this thing allows us to easily remove duplications from some entity. Like you have a list, you can typecast it to set and then again typecast to list, and you will only have the unique elements. Even in a string, you can if you construct a set out of a string, then you get only unique constituent characters. So that's fine. One thing is that that's just a syntactical glitch. Also, you might say you cannot create an empty set in this syntax. That doesn't make an empty set. The reason is this makes an empty dictionary because uh, sets and dictionary both are using curly braces. Dictionaries are differentiated because they have like key colon value, and set has only value, comma value, comma value. So this is an empty dictionary. Do like that. for example, let me comment this line and run. So you will see S1 is a dictionary right now, naturally. So the only, if you want to start with the empty set, and then maybe you want to add elements, because a set is a dynamic thing. You can add things, remove things, all that. So you have this syntax set with empty bracket, and you can start with the empty set in that manner. That's okay. Removing duplications we have seen. Now, how do we create a set? If we just take help, let's say we say help set, and you will see this thing set with empty braces. That's a empty set being created. Set with a iterable, any iterable, it will create a new set object based on that iterable. So that's a big thing. In a single statement, set iterable, you can reduce that, you can pass a list, and you will get a set having the unique members of the list. Any repeating thing will be discarded. You can have a string because it's an iterable, and you will create a set of characters, and any repeating characters will be discarded. You can have a tuple. Tuple is iterable, and the same thing. You will create a set of unique elements. Any repeat will be discarded. Same for even range. And even if you pass a dictionary, any iterable can be passed. If you pass a list, and even the list may have repeating things, so you get a set of unique things. If you pass a range, you get that set. If you pass a string, you get set of characters which are not repeating. And if you pass a tuple, and the tuple may also have repeating things, you get a set of those constituent elements which are unique. Any iterator, from any iterator, you can easily create a set because the constructor of the set is allowing that. Okay, no mutable items in the set are allowed. Okay, you can have a length of the set, that's okay for any container. Typically it has empty set we have seen. Some set operations, let's just understand. There are a lot of, if you do help set or you see the website, you will get a lot of information. So you can add an element to a set. If it is already existing, it doesn't do anything. It doesn't raise an exception. You can clear the set totally, that make it blank, make it empty. When you do something like S1 equal to S2, by default, you will be pointing two references to one object. But in case you want to make a shallow copy, you can have a S1.copy, that kind of thing. Difference is A minus B basically. A minus B means all the elements in A which are not in B. So, and you will often find these pairs. You will have difference, difference update, intersection, intersection update, like that. So, difference update means that compute the difference and update the object on which I have called with the difference. It is like, so difference is like A minus B, and difference update is like A is equal to A minus B. That update the object with the difference. So you will find this pairing and X underscore update often. Discard basically means that I'm giving an element, remove it, discard it, avoid it. And it is like forgiving. If the element is not there, it does nothing, doesn't raise any exception. Intersection, we know A and B means all those elements which are present in A and present in B. Intersection update means again A is equal to A intersection B. That means update A with the result of the intersection. Isdisjoint, you can understand two circles who are just not overlapping at all. That means there is no element which is present in both sets. They are disjoint. Issubset and issuperset is the same thing. Subset and superset. Pop is an element, remove we saw some discard a little up that uh, discard, we were giving an element. Take this element and discard it. Pop is like, get me some element of the set and remove it. So if you want to like iterate to the set in a destructive way, that I want to iterate, give me each element, while giving to me, remove it. I don't want to see it again. I will process it and that's the end. So you can, in a loop, keep calling pop and it will keep returning an element. And if it is empty, it raises an exception. So this, I mean, we must be clear, like when the functions will raise exception and one when they will be silent. So you need to be careful. Remove is again similar to discard. We are giving an element and we are saying remove this element, remove 10. But it is different from discard that in the sense that it raises an exception, key error, if the element is not present because you are unable to find the key. Discard, if we see a little up, was forgiving. If it is not present, do nothing. Okay. Symmetric difference is those elements which are present in one but not in another. That means mathematically you can say A minus B, all the elements which are in A but not B, union B minus A, all the elements which are in B but not in A. So symmetric difference, the ones which are present in one but not in another. Union is union, A or B, like any, I mean, uh, all elements which are present in at least one of the. Update is updating with the union, something like that. So here you don't have union and union underscore update, but similar relation exists between these two, union and union underscore. So let's see some small demo we will see. Not s1 dot add. So naturally you have an element, you have a set, you can add 9. If you add, it is forgiving. If you add something which is already existing, doesn't bother. Fine. And yeah, clear clears it totally. It will be empty. So understandable. We had a set 1, 2, 3, cleared it. We got empty set. Most of the objects they typecast to bool in an appropriate way. So for a set, the appropriate thing is if it is empty, it is false. If it is non-empty, it is true. So that's how it behaves. Okay. So most of the objects will have that behavior. Of course, you can check it in a variety of things. You can check against length also if you are doing such a check. That if length is not equal to 0 or whatever. So all that thing exists, and when you are dealing with sets, you have, in fact, any object. Let's say you have this two objects, and so you remember that you have this facility of checking whether they are equal. So in this case, it is true, they are equal, and you have a facility to check whether they are the same object. S1 is the same as S2. So that is false here because they may have the same content, but they are different objects. So S1 is S2 is false. And if you modify, if you say S2 equal to S1, then this thing will become true. So always remember is versus double equal to. Concept of reference, we have seen it a number of times. If you say S2 equal to S1, they are actually referring to the same object. If you delete S1, even then the object in this case will keep living because there were two references referring to the object. One got deleted, but the object is still alive. So in those cases, if you want that I want to have a decoupled kind of copy, you can always do a shallow copy using s1.copy. Then changes in one will not affect the other. That's okay. Difference, we have discussed what it is, like 1, 2, 3, 4, and 2, 3. So S1 minus S2 means all elements in S1 which are not in S2. So that would be like 1 and 4. So behind the scene, when you do S1 minus S2, you know that it's a magic function or dunder function, double underscore function being invoked. You know S1 minus S2 literally means this special function. So this does the same thing. By the way, many functions have a corresponding operator overloading also. So when we have S1 dot difference S2, there is a easy syntax for that S1 minus S2, which is very intuitive, right? S1 minus S2. So those operators are doing the same thing as the corresponding functions. S1 minus S2 will do the difference. Virtually for everything, even for subset and superset, you can have such notations. S1 less than S2 means S1 is a superset of S2 and not just a superset, it is a proper superset. It is less than S2. And if you want a superset, that means every set is a superset of itself, equal kind of thing. So you can say S1 less than equal to S2. So sets implement all that difference, union, intersection, superset, subset, checking via the intuitive operators also. We will see. Right now we are at uh, difference, so we see this minus is used for difference. That's fine. Difference update we talked earlier. S1 dot difference update S2 is basically same as S1 is equal to S1 minus S2. So if I run that, I get 1 4. And if I change the code and I run this different way of writing things, S1 is equal to S1 minus S2, that should also work. Why not? And that gives the same result. So you can really use the intuitive mathematical familiar notation. So discard, if you take the help, it removes an element, and if element is not present, do nothing. Okay. So I have this set 1, 2, 3. If I do discard 5, it does nothing. There is no 5. And if I say discard 2, it discards 2. It removes it. So that's what it does. That's fine. It's a forgiving one. It doesn't raise any exception if something is wrong. Intersection, we know. A intersection B, we understand. If there are two circles, the part which is overlapped by the two circles, the elements which are present in both. So 1, 2, 3, 4 and 10, 2, 3, 20. So 2, 3 are present in both. So if you do intersection, you get 2, 3. And you have this operator and ampersand, which does the same thing. So you can choose to use whichever syntax looks good to you. Obviously, this is much more crisp and clearer, ampersand. So that's okay. Uh, just be very careful that it is ampersand. Don't use and here, okay, because and means the logical and means that true and true are true, true and false are false, and basically means that logical ORing. We don't want to do that right now. So if you write A and D, you will be facing issues. So let's see. Intersection update, as I said, it is like compute the intersection and update it into S1. So S1 becomes 2, 3. And of course, you can use the easier syntax S1 is equal to S1 and S2. That's fine. In the same breath, once we are talking of intersection, so union has the same thing. Ampersand, this and for ampersand and or for ORing. This OR is very similar to bitwise or that kind of a thing. Again, careful. Don't use or, which is like the logical or. Logical or means false or false is false, false or true is true. So don't use that. But you can use this for kind of thing. So, but what happens if I use and, then what will happen? So let's just look at that. If I use and, then S1 is computed as a one expression, and if it is false, if S1 is false, then S2 is not computed and the final result is false. If S1 is true or equivalent to true, then S2 is computed, and if S2 is also equivalent to true, then the entire result is true, otherwise it is false. So here what you will see when you run it, you will see what S2 comes is S2 will take this value. So the rule is that if you have booleans true or false, then whatever I told is holds true. But if you have some other objects which are like equivalent to true or false, but they are not true or false, they are some other value. So in that case, it returns the computed value, whatever it was. It will return S2 in this case. So what you will get returned is this value, not the intersection thing. So you will see that it is 2, 3, 10, 20. And if I make S1 false itself, let's say I make S1 empty set. So I have to use set. So S1 itself is false, then S2 will not be computed, and this value will be the return set, empty set. So the type of the return value will actually not be false, it will be empty set. So let me run that and you get empty set. If you even ask for what is the type of that thing, so it is a set. So when you are mixing things and when you are doing logical expressions with different objects, so it is like the last computed object that is returned. It doesn't convert it to literally false or true and then return. So naturally we don't want that. We were not comparing things as true or false. We wanted to do intersection. So that's why I said don't use and, don't use or for union, or for union. If you are using union, want to do union, either use this symbol or say S1 dot union S2. Okay, is disjoint is clear? Are they disjoint or not? So this assert is, assert is a friend of any developer who wants his code to be tested automatically when it executes. You have some loop invariants and you want to say that this must be true. So the same way I have written that whatever this result is, it must be equal to the same result which, so disjoint means that take the intersection and that intersection must be empty. So this is like a self-test kind of code. That's that's okay, no problem. Subset, superset, of course. Subset means A is subset of B if all elements of A are also in B. So by definition, A is a subset of A. It's not a proper subset, but it is a subset. So you have very convenient notation. Less than, if you say one set is less than another, so it's not that length is lesser. It means that S1 must be a proper subset of S2. So in this case, I can say S1 less than S2 is true because S1 is a proper subset. And subset means that it may be equal also. Two circles who are just equal and coinciding totally. So you can have less than equal to. You can have greater than and greater than equal to for superset. Just like you have subset checking, you have superset checking. You can have greater than operator. S2 is superset of S1, proper superset, or S2 is superset of S1. So you have this is subset is superset. I think that's quite intuitive thing really to discuss there. So that's fine. Pop, as I said, it removes any arbitrary, remove and discard took an element and they removed it. Pop means that I don't know what is the content. give me one element and I will deal with it. And it raises a key error also if it is empty. So what is this code? It is just in an infinite loop. It is keep popping. So who will interrupt that infinite loop? Key error exception. So let's run it. So it popped 4 elements and finally it got key error. So if you want to, in a like a destructive read, whatever I have read, remove it. I read only once. So you can do that. Remove and discard, we had seen. Discard was for giving. Remove is like non-forgiving. If you remove something which doesn't exist, it raises an error. So like you removed it and now you are removing 2 again, it will say key error. That's fine. And you can cache the exception. Symmetric difference, basically this thing. A minus B union B minus C. So all the elements which are present in one but not in another. So 1 is present here but not in another, and 4 is present in here but not in another. So 1 comma 4 is the symmetric difference. Fine. Union and update, they are the same pair. Union, you get a union. We already saw this when we were saying ampersand. We saw this operator. Or obviously stay away from AND and OR. And that's fine. Union has one peculiar thing. So when you read the document, you find this interesting phrase which I was looking for. Update, intersection update, difference update will accept any iterable as an argument. That means when you want to like take a union, so naturally you can do something like this: S1 dot update S2, and S1 will be updated with the union. So that's fine. But you can also say S1 dot update any iterator. So that means I can even say a string, and this S1 will be updated with elements of that string. So it doesn't return anything, but if I print S1, it is updated with that thing. And if something repeats in that string, obviously it will not be repeated in the set. So you can update things with any iterator. If you have some more content for the set, waiting in a list, for example, let's say you have some list and you want to add those in the set, with that iterator, you can just add any iterable will do. So that holds for some functions, these ones, intersection, difference. So when you have a set and some other list or tuple or some other iterable, you can do some of the operations with them. But I think those are nitty-gritty programming details. When you actually get down to code, just keep an eye on the man pages and documentation. And I think it's easy to navigate. You can just come here and this tutorial and library reference, at least these two you can keep an eye on. Library reference has for all different classes and data types, it tells what all can you do as a reference document. Filtering out common words. So it is just like you have a kind of a paragraph or a chapter and you have some common words in a set and you want to filter out those things which are common. You want only the words which matter, which are of significance. Is the A, you want to remove them. So maybe you can, this is a rather simpler code. You iterate through the entire list, and if that is not in common words, only then you keep it. Something like that you can do. When you, I mean, you might soon or later encounter those some function tools, you may want to call it, or functional programming also, perhaps you can use the term. But things like map, filter, reduce also possibly. But map and filter, they might come your way. Map basically means that I have a collection of elements. I want to apply some function on each of the elements. Okay, so that's map. And filter means I have a collection of elements. I want to filter elements which are satisfying a condition. Okay, so this solution for the same thing is like I give a filter function. This highlighted thing is a filter function, and I am saying that this list L1, which was the all the words stated, apply this filter on that list and give me the result. So what does filter return? Filter doesn't really filter and process and return the entire thing. It doesn't do that. Filter returns the iterator, or you may say a generator also. Filter says that here is the object, and so let me just do it one step at a time, and then it will be little clearer. So let me say I have got this list of words, all the words, and I want to now filter out the common words. So now I can do something like this. I can say this little thing, and I will call it F1, just like that. May not be a great name, but I will say F1 is equal to filter this. And I will ask what is the type of F1. So F1 is a filter object. You can consider it a generator, iterator, something. But it has not really done anything. All it has done is it has noted that I am a generator who will, when asked, keep returning the filtered thing. So for seeing the whole thing, I can either iterate through it and I can print it. Then I will see the filtered words, or I can do convert it to a list like I did here. So that's what this code is doing. That it's saying my condition is that that thing should not be in common word. If that is so, filter it. I mean, select it. Otherwise, filter it out. So sooner or later, this filter map, these kind of things may come your way. Lambda functions we have already seen. Given this variable, compute this expression. And for me, the expression is that the expression is a Boolean condition. The lower case of x is not in this list. That expression is there. Of course, you can always write in function, common function for you. I mean, and then use that, but or you can use a lambda function, anonymous inline function. Set comprehension, I think we saw also. You can use it in the same way as you use list comprehension, dictionary comprehension, everything. And because there is no syntactic ambiguity here, by the nature of the value, it will know. If you write x, you are creating a set, and if you write x mapping to x star x, then you are creating a dictionary. So no confusion really. Python knows whether you are creating a set using set comprehension or creating a dictionary using dictionary comprehension, but the syntax is identical.